Hello everybody, I'm Chung. I'm going to give a presentation about our CAADRIA proceeding entitled Using Virtual Filter to Measure How the Elderly Perceive Color. What I'm trying to do is to look at different color distinction of elderly people from young people on digital interface. This year to 2025, estimated 200 million of world population and 2 million of Korean who will experience color distinction problem related to age. 500 million of world population will suffer from xanthopsia, but within 5 years from now, 20% of Korean are over 65 years old, that is 10 million, and in 2067, elderly people are 80% of the world, when Korean elder rates are 46%. So I respond to this super aging issue of future color environment. I have a question for guys color environment for all, because if you cannot see green and blue on black background, you do not know change of traffic sign when you are older, and it happened with 1/4 also over 60 years old. You may think there is a audio guide for simple information if you cannot see the green light. Look at this complex color information. We use color because color identify instantly on this complex information. This Seoul Metropolitan Subway map is most widely used in South Korea. This subway map is seen by 7 million passengers every day, 1 million of whom are over 65 years old. Subway lines are shown in 9 colors on its map with much more complex combination of colors. These standard colors be based on Pantone color chip that Seoul Metro determined. When people's crystalline lens get old and not like crystal transparency anymore, green, blue, and purple are the color with the short wavelengths, visible lights, and also color with people lost the ability to perceive as they age. There was optical study using artificial lens. This is the human lens, and similar conducted by the artificial lens, Y2 for 450 of the violet, and the Y3 is for blue, and DG for violet to green. I have 3 of lens, but there is no longer in production Y3 and Y2. The present study was conducted to create a virtual lens by comparing result of this study using artificial lens Y2 and DG. Right picture is mapped through digitized the Y3 lens. You can see that visual accessibility of subway map remain a challenge for elderly people. I digitized the YA3 artificial lens on previous study. Now I try to visualize DG lens on digital interface, because the objective of this study was to develop a digitized virtual filter to represent artificial lens to help elderly people better read the map. In this background and related work, my research question with the virtual filter study was conducted by address that affect the way map color perceive. These 3 questions will be valid. How virtual filter represent color as they perceive can be confirmed by colorimetry on CIE LAB. Lens color value were adjusted based on comparative study of artificial lens of elderly people. First, the change color perceived by elderly people were measured by spectrophotometer with color from color chip viewed through artificial lens. Spectrophotometer measurement were taken common application of CIE luminance D65 using visual field that substandard 2 degrees standard of central fovea. This is standard, but a person asked me why using daylight to measure subway map seen in underground, that is indoor. So I answered that is standard of pure white element as you see. For measure, it means color temperature is 6504 Kelvin, And underground LED standard is also D65 actually. Therefore, you can put color value on VR or other digital interface measured by this illuminant. If you want to dim the light source, you can see different color appearance, like when we see different color in dark. Now I focus on changing colors from the lens transmitters change, not how dark image change the color perceived. For that, I measure the color by standard illuminator standard D65. I put the color value of virtual filter on CIE LAB. Perceived color CIE LAB space is similar to human eye lens perceive. Is 100 is for black and 0 is white. It is Cartesian coordinate to 3 dimension. There is a x-axis of A and y-axis of B. It is the delta E score under 2. It is kind of 1. There is a 0 to 100. It is same color, and the 100 it means complementary color, totally different color, and 10 means the similar color. So this distance on the 3 dimension have kind of show color difference, and I calculate by delta E 2000. Spectrophotometer value input in Excel file where visual formula algorithm was run on them automatically. After color chip value for Seoul Metro survey map standard color collected, I want to make the artificial lens to virtual lens, so transferred by artificial lens. It is measured by spectrophotometer. Second, Dynamo was used to predict this type of color data. This easy to check and adjust than real lens. Real lens have limitation to explore the virtual filter. These values were noted, compared, and adapted for digitization of color change result of artificial lens to interface with the lab using Dynamo. Variance independence based on color range and transparency. The cause belongness of red, green, and blue defined into operate combination of 0 to 255 corresponding color panel on interface. The lens was set glazed glass, that is, I put the RGB on this glazed glass, and I already put the color panel, the standard color RGB, and I want to find the same color transmitted through the artificial lens and virtual lens. These transmitted results were compared with those produced by the lab interface. The delta E 2000 score was calculated to determine each color chip position on the 2-dimension or 3-dimension CIE LAB map produced by a virtual filter applied to the artificial lens, and the validity of the digital based on reliability was verified is under 2 of delta E. For Y2 lens, there has a limited adjust exact value because of the B, RGB, and the B value need to be minus, but there is no minus on RGB, so it could only approximately simulated and implemented. That was not perfectly valid for Y2 lens or for virtual lens. And for the digital lens, it is valid perfectly, and the saturation decrease because of the variance of color space RAB. The center is white and black, and that is
getting darker. The visual light transmission decrease makes green near to black. The purpose of this study was to determine which virtual filter could be used accurately represent the map color for elderly viewer, and that is the delta E 2000 score was less than 2. Thus virtual filter successfully represent the target color, yellowing up virtual lens accurately simulate that the color through virtual filter value it is. There was a question for this research: what is color value transferred artificial lens? It is the value color information discrimination that we can find the same thing with the digital value of this. That is the virtual filter transfer the color value, and there was a difference in color value between artificial lens and virtual filter. Before slide I talk about this. Therefore, this research concluded that color on distal interface of survey map transfer virtual filter change and affect the color perception that are comparable with the artificial lens produced by short-wavelength transmittance of a DG artificial lens. I made a virtual lens of this from this study. Elderly people will not be able to perfectly see every color, the violet, blue, green on the black background. We can think of easily, but we need to put on the color. Maybe the virtual reality can be the solution to simulate that. So there are the other potential combination we can find that would be able to perceive more easily. I will try the next study with the AR lens of this. Thank you for listening.